serial correlation, right? So once you believe there is a serial correlation, and say that you are analyzing financial data, and of course, at the field of finance, is really you do have a high probability of having a serial correlation, of course, and most likely you have a positive serial correlation because if you are investing in stock and the stock market price stock market at day one and at day two, it's really highly possible that a lot of investors will just jump on the wagon, right? Jump on the rocket because they want to get the momentum. So to be frank, there are a lot of trading strategy called a momentum strategy. They will just go with the momentum, whether you have a good or bad fundamental. So they will just go with the flow, go with the momentum, and of course this will result in our data. We have a positive serial correlation. So the positive serial correlation, if you do know that you have a positive serial correlation, does this affect your regression analysis? Of course, it will affect the regression analysis, but it just won't affect the coefficient. The estimate coefficient say that you are doing a regression, and the regression be something like this: y equals to a1x1 plus a2x2 plus all the way up to anxn plus maybe b and plus epsilon. So if your regression or something like this, and there is a positive serial correlation, and it's just only affect the error term, but it won't affect all these coefficients. So the coefficient estimate will not be biased, which means that will not affect the coefficient, but most of the time you will not face with the multiple regression, but rather you will face with the maybe just something like this. Let me just give you an example. So most of the time you get time series. So the x will most of the time will be x, and there will be just b1 and plus b0 plus epsilon. So most of the time we'll just get this, right? And this will be a lot simpler than the previous example that I am giving right now. And I think CFA will probably just give you a very simple example because they don't want to overcomplicate things. And if they give you this example, and certainly this example will be the same as the example I gave you, the B1 will not be affected by the serial correlation of the error term. So once I said there is serial correlation, especially the positive serial correlation, is all connected with the error term, but rather it's all connected to the error term, but it will not affect the coefficient. So it won't affect the coefficient estimate, but there is a very big but here, because we do have a serial correlation problem. We need to solve that. The serial correlation will make the standard error a little smaller than the if it's calculated correctly. Why is that? If you just draw error terms map here, since it's a serial correlation, it can't just smooth all this error. So the standard error of the estimates will be smaller. So once the SE will be smaller, there are two indicators that there are two things that will be affected. The one thing is T statistics, of course. The other is the F statistics. Okay, so let me just write all the influence that they have. Right. First, serial correlation do not have any influence with the consistency of the estimate regression coefficient. So will not have effect on coefficients, will not have any effect on the coefficient, and when you have a, say, positive zero correlation, it will get the standard error of the estimate, which is just the error terms, standard error, right? And of course, the variance will make that small. Once you got that small, you will certainly affect the t statistics, because you know the t statistics is just the b1 and s here. So if this small, t will be big. So this will result in the type 1 error. Why is type 1 error? Type 1 error is just reject the true and accept, kind of accept the false, right? That's how type 1 error works. If originally, if that's just 0.01, which is not at the rejection region, but you have zero correlation, so the standard error will be small. The standard error will be small, and the t just rise to say 10, and that will definitely result in the rejection of the non-hypothesis, which means that the original is true, but we just reject the true, and kind of accept the alternative hypothesis, and you kind of accept the false hypothesis. Okay, so that is not the error we want to make, and this error we call that type 1 error. Of course, if you want to know the type 2 error, we just flex the rejection and accept. Okay, so reject the false and accept the true, and kind of just the t value. I think that standard error is too small, only will result in the type 1 error. So don't forget about type 2 error. Okay, so you don't need to know that. And let me see what else you will affect. Of course, the f value will be affected. So the f statistics will be unreliable, because you know that the f is equal to the standard error of the regression multiplied by the standard error of the estimate, and of course we need to adjust to the degree of freedom. So the degree of freedom is k, of course, and this degree of freedom n minus k minus 1, right? So since the SSE will be affected, so SSE will be small, right? Because the standard error that is too small, so the SSE will be small. Once SSE be small, the f value, I think, will be just unreliable. I think that's the partly depends, but since the SSR and SSE, we can't just make the conclusion by just writing that. But since you do include SSE, so it's not reliable. That is the one thing we can be sure. Let me just write the what I can be sure here. Unreliable, right? And just need to memorize. This will result in type 1 error, and this will result in unreliable estimate. I think that will be suffice, right?